Okay, we're starting with lesson 5.3 right here, and it's logarithmic functions. And we're going to use the basic fact that the log of 1 is equal to 0. And the reason why that is because a log is really an exponent. So when you use the letters log, it's really base 10. So that means is 10 to what power is going to give you 1. Well, in this case, 10 to the 0 power is going to give you 1. So therefore, the log of 10 a log of 1 should equal 0. So why does that matter? When we're looking at a graph, I know if I put a 3 in here, that's going to make this log of 1, and we know that answer is 0. So we're looking for the point 3 comma 0. So look here, that's 2 comma 0. 3 comma 0 is here, 3 comma 0 is here. So therefore, this is going to be the right graph. We just have to match up which graph matches. So it's a big idea, is that log of 1 is equal to 0 because 10, we always do base 10 if it's log, 10 to what power equals 1. That's the actual way to look at that. So for instance, we're trying to find the log base 10 of 10,000 is equal to what? Well, what does that basically mean? That means 10 to what power equals 10,000. Okay, so log is really an exponent, all right? And if we're not told otherwise, we're using base 10. That means 10 is the base. 10 to some power equals something else. So this is the exponent, so it's the base stays the base, okay? The logarithm becomes the exponent, and this 10,000 moves over. So 10 to what power equals 10,000? And that's going to be 4. So x equals 4 because 10 to the 4th power equals 10,000. Now moving over here, the log of 7x base 4 equals 2. So what does that mean? We have to rewrite this. This is called log form, and we're trying to change that to exponential form. And the way you do that is take the number that's in the base. So the base here is going to be 4, and the log, so the base stays there, and the log is the exponent, so therefore this becomes the exponent, 4. In this case, yeah, so 4 log is the exponent, 4 squared is equal to, and then the number you're taking the log of goes on the other side. So you're going to get 16 equals 7x, so you're going to get x equals 16 over 7. And the general rule here is when you're changing the base, okay, stays the base. The logarithm becomes the exponent, and the number you're taking the log of just goes to the other side. An example to remember is something like this, because you know that 2 to the 3rd equals 8th, right? 2 to the 3rd equals 8, therefore 2 to the 3rd equals 8. You can remember that example. I always remember that in my head. It helps me figure that out. So, for instance, over here, we're trying to figure this one out, number 4. And it says we have this. So, the trick here says ln of e to the x equals 22.7. Well, there's a rule that we need to know, and that is that the ln of x and e to the x are inverses. So what that means is that the ln of e to the x is equal to x because they undo each other, and okay, e to the ln x is equal to x. So whenever we have both functions together, it's going to undo one another. So the ln of e to the x is equal to, so this is going to be x, so therefore x equals 22.7. So you can do that one straight away. And here it is, here's the function. So ln to the x and e to the x are inverse functions. They undo one another. And the two basic rules are when you take the ln of an e, it brings you back to x. When you take e to the ln x, it brings you back to x. All right, that's what you need to know. Now here, all right, so we just change it from log form to exponential form. There's the base, so it's 1/8. 1/8 to what power? The logarithm becomes the exponent. And then we're taking the log of goes to the other side. So 1/8 to the x is equal to 64. Well, we know that 8 to the 2nd power equals 64. So therefore, we just have to make this a, instead of a positive 2, it's going to be a negative 2. So it's going to be 1/8 to the negative 2. So therefore, x equals negative 2. So when you change the exponent from positive to negative, it just takes the reciprocal of the base. That's what's happening there. And there's your rule. So a to the negative b equals 1 over a to the b. Or if you have 1 over a to the b equals c, you can just take the reciprocal a and make that negative b, and that equals c. That's the rule that I use right there. Okay. Next problem, number 6. You're given the function log log of x space 2 is equal plus 3, right, to figure out which of those graph matches. And you want to look at, again, the 0 point. So you want to look for a log of 1. If I put a 1 in here, I know that's going to be a 0. So if I put a 1 in there, I'm going to get 0 plus 3, 3. So I'm looking for the point 1 comma 3. And it looks like it's going to be right here, 1 comma 3. So it looks like this one. These are really close, but definitely not this one. Okay, that's not this one. Definitely not this one. 1 comma 3, no, that's in the wrong section, so it's definitely going to be this one. So pick a point that's easy to pick on the graph. Log of 1 is equal to 0, and so you're going to get 1 comma 3. And that's going to match this graph right here. Now number 7. They're asking us to solve for x. So again, this is log form. We're going to write it in exponential form. So we're going to get 5 logarithms of x1, 5 squared is equal to 2x minus 1. So we're going to get 25 is equal to 2x minus 1. So I get 2x is equal to 26. So x is equal to 13. Alright, so log is an exponent. So that means you have this one, you're going to write an exponential form as well. So that's all they want for this problem. They don't want you to actually figure it out. They want you to just write it out, write an exponential form. So it's going to be the base is 4.4. Okay, the logarithm becomes the exponent. So 4.4 to the 3x is equal to, and then the number you're taking the log of goes to the other side. Okay, so it's going to be 4.4 to the 3x power equals 3.6. All you had to do was write that one out. Now for number 9, you have 3 to the this business equals 9. So what does that mean? Well, we know that 3 squared is equal to 9. So therefore this mess must equal 2. Therefore log of x space 2 is equal to 2. So now we can change it from log form to exponent form. So that means I'm going to have 2, the base 2. The logarithm becomes the exponent. 2 squared is equal to, bringing the number taking the log of over here. So 2 squared is equal to x, so x equals 4. Alright, now number 10. What are they asking for? They're trying to ask you to solve for x most likely here. Alright, so we're going to solve for x. So we have our base. And the only way to undo this natural log is to take the e of both sides. That's what I would do. So we know that e to the ln x is equal to x. So I would take the e of both sides. If you do that, that gets rid of the natural log. And then you're left with 7x plus 11. So 7x plus 11 is equal to e to the 4th. And then you subtract, and you're going to get 7x is equal to e to the 4th minus 11. And so you're going to get e to the 4th minus 11 over 7. Alright, so the trick here is that when you have an ln, in order to undo an ln, you can't divide. You have to take the e of both sides, and the reason for that is that e to the ln x is equal to x, okay? It undoes it. So ln and e are inverse functions, that's how you undo one another, and if you take the e of one side, you have to take the e of the other. Number 11, you have to write this in the simplest fraction form as possible for number 11. And we'll do that right now. So basically what's going to happen is you have ln of this, so I'd write this in fraction form. So you're going to have ln of e. Now this is 8 power, so it's going to be ln of e to the 2/8, which really equals ln of e to the 1/4. Well, ln of e to the x, remember ln, okay, of ln of e to the x is equal to x. So therefore, the ln of e to the whatever, that's equal to just 1/4. So e to the ln x and ln of e to the x is equal to x. Okay, so remember those, they undo one another. So the answer for that one is just 1/4. Over here we have to solve 12. It's going to be 16 base, right? This becomes the exponent. 16 to 3/4 equals, remember what you're taking the log of goes near the side. So that's the 4th root of 16, which is 2. 2 to the 3rd power is equal to x, so therefore x is equal to 8. 13. We get, here's 13 up here. We need to find out which graph that works. Now, this is a plus. The key points are when this is going to be log of 1, so I would try like -3. When you put -3 in here, you're going to get 2 minus log of 1, which is going to be 2. Okay, so you got negative 3 comma 2. That's the key point. Also, if you put 0 in here, it's going to be log 4. Log 4 is going to be a little bit above, a little bit above 0. So you have 2 minus, like, a little bit above 0, so you have something like 1.5-ish, right? Approximately. You can try to calculate it out. So we look at negative 3 comma 2. Well, if you look at these choices, this one's there. Nope, a negative 382, yeah, that one is there. Negative 386 is before 2, so it's close, but not quite. This one's definitely not right. Also, you have 0, 1.5, so this one's definitely not right. So when you put in 0, you gotta have a little over 1.5. This one's not right. 0, 1.5. So these two are pretty close. So I take a look here, and this is negative 4. So this is the mark, because x can be between negative 3 and negative 4. And here it stops at negative 3. And plus negative 3, 2, clearly. So that one's going to be your best answer for that one. All right, so that answers our questions for 5.3.